Question 8, Part C. Wheeler Barroback Shire Council borrowed $3 million at the beginning of 2005. The annual interest rate is 12%. Each year, interest is calculated on the balance at the beginning of the year and added to the balance owing. The debt is to be repaid by equal annual repayments of $480,000, with the first repayment being made at the end of 2005. Let AN be the balance owing after the nth repayment. Part 1. Show that A2 equals 3 times 10 to the power of 6 times 1.12 to the power of 2 minus 4.8 times 10 to the power of 5 times 1 plus 1.12 in brackets. To make the solution a little easier, we can work abstractly, in other words, working in algebra, and then substitute the values right at the very end. So I'm going to let P equal 3 times 10 to the power of 6. So this represents the amount borrowed in scientific notation. This is $3 million. I'm going to let R equal 1.12, and this represents the percentage increase that the bank imposes on the loan. So that's a 12% increase per year. And M represents the value of the repayment, again in scientific notation, which is 4.8 times 10 to the power of $5, or $480,000. So A1, which represents the amount owing at the end of the first year, is the amount borrowed increased by 12%, take away the repayment. So PR minus M. Now the amount owing at the end of the second year is equal to the amount owing at the end of the first year, increased by 12% again, so multiplying that by R, and then taking away another repayment of $480,000. But A1 is PR minus M, so substituting PR minus M for A1 here, we get A2 is equal to PR minus M in brackets times R minus M. Expanding the brackets, we get A2 is equal to PR squared minus MR minus M. And then factorising out negative M, we get A2 is equal to PR squared minus M times 1 plus R in brackets. Now we can substitute the values for the variables. So A2 is equal to 3 times 10 to the power of 6 times 1.12 to the power of 2 minus 4.8 times 10 to the power of 5 times 1 plus 1.12 in brackets as required. Part 2. Show that AN equals 10 to the power of 6 times 4 minus 1.12 to the power of n in brackets. From part 1, the amount owing at the end of the second year, A2 is equal to PR squared minus M times 1 plus R in brackets. Continuing the pattern for A3, the amount owing at the end of the third year, we have A3 is equal to PR cubed minus M times 1 plus R squared in brackets. We can generalise a pattern from A3 for AN, which represents the amount owing at the end of the nth year. So AN is equal to PR to the power of n, and we get that matching the subscript with the index here. And noting also that the highest power of R is 1 less than the subscript of A. So if that's n, this has to be n minus 1. So we get AN is equal to PR to the power of n minus M times 1 plus R squared plus dot 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 plus R to the power of n minus 1 in brackets. Now inside the brackets we have a geometric series. We have n terms, first term 1 common ratio R, so we can replace what's in the brackets with the sum of a geometric series formula. So AN is equal to PR to the power of n minus M times 1 minus R to the power of n over 1 minus R in brackets. The next step is to substitute the values for the variables in this formula here. Substituting the values for P, R and M and expressing the sum formula in division form rather than fraction form, we get AN is equal to 3 times 10 to the power of 6 times 1.12 to the power of n minus 4.8 times 10 to the power of 5 times 1 minus 1.12 to the power of n in brackets divided by 1 minus 1.12 in brackets. Now 1 minus 1.12 is equal to negative 0.12. And dividing negative 4.8 times 10 to the power of 5 by negative 0.12, we're dividing a negative quantity by a negative quantity, which turns it into a positive quantity. And 4.8 times 10 to the power of 5 divided by 0.12 gives us 4 times 10 to the power of 6. So AN is equal to 3 times 10 to the power of 6 times 1.12 to the power of n plus 4 times 10 to the power of 6 times 1 minus 1.12 to the power of n. Expanding the brackets here, we get AN is equal to 3 times 10 to the power of 6 times 1.12 to the power of n plus 4 times 10 to the power of 6 minus 4 times 10 to the power of 6 times 1.12 to the power of n. We have two like terms. We have this term here, which can be combined with this term here. So we have 3 lots of 10 to the power of 6 times 1.12 to the power of n, taking away 4 lots of 10 to the power of 6 times 1.12 to the power of n. And this is our constant term, 4 times 10 to the power of 6. So AN is equal to 4 times 10 to the power of 6 minus 10 to the power of 6 times 1.12 to the power of n. Finally, factorising out 10 to the power of 6 from both of these terms, we get AN is equal to 10 to the power of 6 times 4 minus 1.12 to the power of n in brackets as required. Part 3. In which year will Wheeler-Barrow Shire Council make the final repayment? The loan is completely repaid when the value of AN equals 0. In other words, we want to solve the equation for n, 10 to the power of 6 times 4 minus 1.12 to the power of n in brackets equals 0. We can simplify the equation by dividing both sides of the equation by 10 to the power of 6. So we get 4 minus 1.12 to the power of n equals 0. Rearranging this equation to make 1.12 to the power of n the subject, we get 1.12 to the power of n equals 4. Next, we need to isolate the n, and we do that by taking the log base 10 of both sides of the equation. We could alternatively take the natural logarithm or the log of any base, but log base 10 is convenient. So log base 10 of 1.12 to the power of n is equal to log base 10 of 4. Now applying one of the logarithm laws, which says that the n being a power comes out to the front, we get n times log base 10 of 1.12 is equal to log base 10 of 4. And then isolating the n by dividing both sides of the equation by log base 10 of 1.12, we get n is equal to log base 10 of 4 divided by log base 10 of 1.12, which is approximately equal to 12.23. Therefore, the final repayment will be made in the 13th year from the start of 2005. And we get that because we have 12 complete years, but there's still a part of the 13th year where there's still some money owing. And that's why the final repayment will be made in the 13th year. So it won't be a complete repayment or a full repayment, it'll be a partial repayment to pay the loan off in full. And that'll occur during the year 2017.